So this is a question to find the Thevenins equivalent circuit. So to find this, to find the RTH, there's a Thevenins equivalent resistance, and the VTH, there's a Thevenins equivalent voltage. So we will solve for that. So this is a circuit, and the Thevenins equivalent voltage is to be found across AB, and the VTH is to be found, and the RTH is to be found. So step 1 would be to find the RTH, and to find the RTH you will have to open all the current sources and short the voltage sources. So there can be different methods to solve the same problem by even using the Thevenins method, but this is one of the method which I will solve, and I will show you the solutions. So in this method, first I will find the RTH, and then I will find the VTH. So to find the RTH, I will short the source. So when I am shorting that, I will get something like this, and the 15 ohm resistance and the 6 ohm, and this is open circuit here, there is nothing. This is 10, and this is again 4. So these both are in parallel. So I will have to solve first for the parallel of this. If I am taking R1, R2 and R3 and R4, so R1 and R2 are in parallel. So to solve them, I will have to write R1 R2 is equal to R1 plus R2. So this is how. So to find R equivalent of that 2, so it is 15 into 10 divided by 25. It is equal to 150 divided by 25. It comes across close to 6. So now what you have after solving from here, you have a 6 ohm resistor, which was the R equivalent for this parallel of this R1 and R2, and then you have a 6 ohm resistor and a 4 ohm resistor. So this is R3 and this is R4, and you are looking from here, and this is RTH. So RTH becomes all these resistors are in series, so it becomes 6 plus 4, which is equal to 16 ohms. So this is what you have found out, your RTH. So that was your step first. So we have finished the step first, so I will just erase this. So erasing, and just so the step 1 has been found here. The step 1 was to find out the RTH, which is equal to 16 ohms. Now the step 2 is to find the VTH. So to find the VTH in this circuit, so what I will do for the specific case is I will first use a loop analysis, and then I will use a node voltage analysis. So first I will use a loop analysis. So I will assign a loop current I1 to this, and I will assign a loop current to this, but there is no need to assign since this is open, and I will assign a loop current I3 to this. So I will apply. So in this case what I find is that the loop current I3 is equal to -4 amperes, and I can find I1 by writing the equation 20 I1 or 20 plus 15 I1 minus 20 plus 15 I1 plus 10 I1. So I have applied the KVL here to this loop. So in this way what I will get is, I will get the value of I1, that is 25 I1 is equal to 20. So the I1 is equal to 0.8 amperes. So this is what I have found out by applying the loop analysis. So I'll just rub this. So by applying the loop analysis, so the first step was loop analysis. So why I applied the loop analysis was to find the current I1, which is equal to 0.8 amperes. Now I have to find this voltage. This voltage is V2, and this voltage, if I assign the node analysis, so the second step is to do the node analysis. So to find this voltage V2, I can do the node analysis. So again, if I assign the branch currents, I can assign the current I1 coming from here, the current I2 as going towards here, the current I3 as going towards here, and the current I4 coming from here. So I already know my current I4, which is equal to 4 ampere, which is given. And again I can write a KCL equation to the node V1. What I will get is, I will get I1 plus I4 is equal to I2 plus I3. So this is if I can write this as my first equation. Again, if I apply the node equation here, then what I will get is, I will get as 20 minus V1 divided by 15 equal to 0.8, which was what I found from the loop analysis. So I will get my 20 minus V1 is equal to 0.8 into 15. So I will solve, when I will solve this is close to 12, and when I will solve this I will get V1 is equal to 8 volts. So I have found my V1, and now I can use this equation here by substituting the nodes here. So the I1 is 20 minus V1 divided by 15 plus my I4, which is equal to 4, equal to my I2 is equal to V1 by 10, and this is equal to my I1 anyway, which I already know, plus I3. My I3 is equal to V1 minus V2 divided by 6. So if I am solving that, so if I am writing this as my second equation just for reference, and if I am solving it here, what I will get is that I know my I1, which is equal to 0.8 plus 4 equal to V1, which is 8 divided by 10 is equal to 0.8, plus again V1 is equal to 8 minus V2 divided by 6. So this 0.8 into 6, so this is possible to write 0.8 into 6 plus 4 into 6 is equal to 0.8 into 6 plus 8 minus V2. So this and this will cancel, and this is equal to 24. This is equal to 8 minus V2. So when I will solve that, I will get V2 is equal to minus 16. So this V2 which I am getting here is minus 16, and this is equal to my VTH. So this is the voltage across this open. So this is equal to my VTH is equal to minus 16, which I have got. So first I got the RTH was 16 ohms, and second I got the VTH as minus 16 volts. So there's multiple ways to do this, and this is one of the ways which I got the answer to solve this. And so just to erase this and write the equivalent circuit. So you can now draw the equivalent circuit as what you have got is a voltage source, a voltage which is minus 16 volt, and a resistance RTH which is equal to 16 ohms, and this is my VTH across A B terminals. So this is my solution, and this was the answer which I needed.